Welcome to this explainer. Look, we're diving straight into a massive shift happening right now. The chemical industry's huge dependency on water, it's no longer just a standard cost of doing business. It's rapidly evolving into a critical financial and strategic risk. We're going to unpack the hard data and standards to see exactly how vulnerable this industry really is to global water shortages.
Think about this stark contrast. On one hand, you've got the immense, heavy-duty reality of chemical manufacturing. We're talking massive industrial cooling towers pumping out steam, guzzling water just to keep the lights on and the reactions stable. But then, on the other hand, you have the physical reality of our planet right now. Severe droughts, dry riverbeds, parched, water-stressed landscapes. That contrast right there, that's the core conflict. You have the immense thirst of chemical manufacturing directly colliding with dwindling global water supplies. And trust me, that creates a very real, very pressing risk for both companies and investors.
So to really grasp this complex challenge, we're going to follow a literal drop of water through the supply chain. We'll start with the industry's hidden thirst, look at what it means to operate in the red zone, uncover the wastewater liability, and finally, see how companies are turning the tide.
All right, part 1, the industry's hidden thirst, withdrawing versus consuming.
To get why this thirst is so hidden, we have to look at how these plants actually use water and how the reporting standards track it. You probably don't think about water when you grab a plastic bottle or a bottle of surface cleaner, but the chemical industry runs on billions of gallons of water globally every single day. It's an absolutely critical operational input. The standards show its primary use is just cooling down high-temperature machinery and chemical reactions. After that, it's used to generate power and heat through steam. And finally, it's used directly in feedstock processing. Sometimes the water literally becomes part of the final product. Without that water, these highly pressurized, complex systems literally grind to a halt. Zero production.
But here's the kicker: how we actually account for all that water. The SASB standards require companies to explicitly split water withdrawn from water consumed. Water withdrawn is basically everything pulled from a river, the ground, or utility line. But consumed water, that's the water that doesn't go back. It evaporates into the atmosphere during cooling, it gets permanently locked into a chemical product, or it gets discharged somewhere completely different, like the ocean. So consumed water represents a permanent drain on local freshwater resources, and that distinction is absolutely crucial.
Which brings us to part 2, operating in the red zone with the WRI aqueduct. So how do we measure the geographic risk of where all this water is being consumed? Well, we look at this number right here, 80% plus. This specific threshold is incredibly important. In sustainability accounting, companies use mapping tools, specifically the World Resources Institute's Aqueduct Water Risk Atlas, to analyze their footprint. If a facility sits in an area where the local demand for water eats up more than 80% of the available supply, that location is flagged for extremely high baseline water stress. It is literally the ultimate red zone on the map. And if a chemical facility is operating right in the middle of one of these extremely high-stress red zones, they are facing severe threats to their basic business continuity. We're talking about compounding risks here. First, environmental constraints, like extreme droughts, limit the supply, which leads straight to operational downtime. But then come the regulatory and financial hits. These plants are suddenly in fierce, direct competition with local communities, municipal users, and other businesses for literally every single drop of water. As you can imagine, that drives wild volatility in procurement costs. It often forces companies to make massive, entirely unexpected capital investments just to secure enough water to keep the factory doors open.
Let's flip the coin for part 3, the wastewater liability, discharge and compliance.
Because taking water out of the environment, that's really only half the battle. Remember, this water is used heavily for industrial cooling and processing, so it almost never comes out as clean as it went in. Chemical manufacturing generates some serious process wastewater that has to be meticulously treated before disposal. Figuring out how to safely put that water back into the environment makes discharge a massive compliance minefield. The standard lays out a ton of risks associated with this wastewater discharge. Companies can get hit with major violations just for exceeding the daily limits for pollutants, or, get this, even for failing to control the temperature of the discharged water. If it's too hot, it can completely devastate local aquatic ecosystems. And it only takes a single incident of non-compliance regarding water quality or temperature to instantly trigger formal enforcement actions. We're talking administrative penalty orders, super costly judicial actions, and sky-high legal expenses. On top of that, it causes immediate reputational damage and severe community backlash. It's a remarkably quick way to lose your social license to operate.
All right, on to part 4, turning the tide, mitigation and resilience.
So the risks are obviously huge, but the industry isn't just sitting on its hands here. They are actively fighting back through some really targeted innovations. First up, major efficiency efforts. A big one is building these circular closed-loop water filtration systems that continuously recycle industrial wastewater right there inside the plant. That drastically cuts down on how much fresh water they need to withdraw. Second, they're driving process and equipment innovations. For example, upgrading their intake systems to reduce aquatic impingement, which is just a highly technical term for accidentally sucking fish and marine life into the water intake pipes. And third, they're going straight to the source with product innovations. They are literally redesigning the baseline chemistry of their products so they require less water to manufacture in the first place. Pretty brilliant, honestly.
And this brings us right back to the actual SASB accounting standard for water management in the chemical sector. This perfectly illustrates why these standardized metrics even exist. The standard requires hard quantitative data: total water withdrawn, total water consumed, the exact percentage operating in highly stressed regions, and the number of non-compliance incidents. By forcing companies to report this specific data, investors can actually pop the hood. They can see exactly which chemical companies are managing these water risks effectively with closed-loop systems, and which ones are, well, mathematically at risk of running dry.
It really puts things into perspective, doesn't it? We rely on this industry for literally everything, from the insulation in the walls of our homes to the tiny components inside the smartphone you might be holding right now. So the next time you use a basic consumer product, ask yourself, is the invisible, highly stressed water supply chain behind it actually sustainable, or is the well about to run completely dry? Thanks for joining me for this explainer. I hope it gave you a crystal clear view of a really complex challenge. Keep questioning the systems behind the products we use every day.